Hello. Today we are going to start a new chapter, that is applications of derivatives. First we will learn a few important points, and after that we will go to solve the multiple choice questions. Derivatives is used in rectilinear motion. That means where a particle is moving in a straight line, there we can use derivatives. Now, if a particle is at A and it starts moving and goes to B in a time t, then we say that the particle has been displaced. It has been moved from A to B, and the distance it has been moved, it is AB. Now there are two things, displacement and distance. What is the meaning of displacement and distance? Suppose if A is here and B is here. From A, if you want to go to B in this way, then measure, that will be total distance traveled. But you can see the object has started here and ended here. So this will be the displacement. How far it has been displaced. Now, in motion science, displacement is dependent on time. It is the function of time. So, displacement we usually denote by the letter S. S of t will be the function. Now, as the displacement is changing, S is changing with respect to time, then the object gains velocity and it is denoted by V. Now, if the object's velocity changes with time, that means the object has gained acceleration. So, acceleration can also be called as, first of all, you can call it as derivative of velocity, or you can call it as second derivative of the position. Now, because acceleration is dv by dt, we can write it as dv by dx or s into ds by dt. We can write this as dv by ds into v, because ds by dt is nothing but v. So acceleration is velocity times dv by ds. For example, if s is given as p e power t plus q e power minus t, then velocity is ds by dt, that is p into e power t minus q into e power minus t. That's the velocity. Acceleration is derivative of velocity, and that is p times e power t plus q into e power minus t, which is nothing but s itself. Not only this, a particle moves along a line in such a way that s equal to tq plus pt square plus qt plus r. If for t equal to 1, s equal to 7, v equal to 7, a equal to 12, your work is to find p and q. That is the question. So, first we will take t equal to 1. Then s is equal to 7. That means 1 plus p plus q plus r equal to 7. This is the first equation. Similarly, velocity is ds by dt, that is 3t square plus 2pt plus v. If you want to find like we already know, one second, I will write here. We already know that when t equal to 1, v is equal to 7. So I can write 3 plus 2p plus this is r plus r is equal to 7. This is second equation. Next, acceleration is d square s by dt square. That is 60 plus 2p. When t equal to 1, acceleration is 12. So 60, t we will put as 1. Then 6 plus 2p equal to 12. This is equation. So from equation 3, p is equal to 3. If you put p equal to 3 here, 3 plus 6 plus r equal to 7. R equal to minus 2. This is q, not r. Q equal to minus 2. Now because p and q we know, 1 plus p is 3, q is minus 2 plus r equal to 7. R equal to 7 minus 2, that is r equal to 5. If y is equal to f of x is a function, dou x is a small change in x, then f of x plus dou x equal to f of x plus f dash of x dx. Now percentage error. Percentage error is dou x by x into 100, where relative error is dou x by x. Then there are some formulas which you have to memorize. First one, for a circle with center C and radius R, area is pi r square and circumference is 2 pi r. Next, a cube with side x, x, x everywhere. For that, surface area is 4 pi r square, volume is 4 by 3 pi r cube. Oh, I was writing something else. So for a cube, total surface area is 6x square, volume is x cube. The third sphere of radius r, surface area is 4 pi r square, total surface area is 4 pi r square, circumference we will find only in case of circle, but in case of sphere we can find the volume. Volume is 4/3 pi r cube. Coming to the fourth, a right circular cylinder of radius r and height h. Curved surface area is 2 pi rh. Base area is pi r square. Volume is pi r square h. In a cone, apart from the base radius, this will be the slant height, and this is the normal height. This theta is the semi-vertical angle. So in cone, we can write L square equal to r square plus h square. We can write sine theta equal to r by L. We can write cos theta equal to h by L. And tan theta equal to r by h. Base area is pi r square. Curved surface area is pi r L. Total surface area is okay, we will leave the total surface area because it's not that useful. We can write volume is 1/3 pi r square h. Next, in a circle, there can be a sector bounded by r, theta, and length of the arc. L is length of the arc. So, length of the arc L is r theta. Perimeter of sector is 2r plus r theta. Area of the sector 1/2 r square theta. Then we will learn a little about tangents and normals. For example, this is x-axis, this is y-axis. There is a curve. On the curve, there is a point x comma y. Now, at x comma y, if I draw a tangent, the tangent makes angle psi with x-axis. And just passing through P, perpendicular to this tangent, there is a normal. This is called normal. So once you know this, If y equal to f of x is a curve, then slope of tangent is dy by dx and slope of normal is minus dx by dy. Equation of tangent is y minus y1 equal to dy by dx into m minus m1. Or you can write x minus x1. Later in dy by dx, you have to plug x1, y1. You have to substitute x1, y1. Similarly, equation of normal is y minus y1 equal to minus dx by dy into x minus x1. Next, if tangent is parallel to x-axis, then slope of the tangent will be 0. If tangent is perpendicular to x-axis, then slope of the tangent will be undefined. Or dy by dx is undefined, but dx by dy will be equal to 0. Anything we can say. Now, if you want to find length of tangent, the formula to be used is modulus of y root of 1 plus dy by dx whole square by dy by dx. But length of normal will be y root of 1 plus dy by dx whole square. The next formula is length of subtangent. Length of subtangent is y by dy by dx. Length of subnormal y into dy by dx. Intercept, x-intercept of tangent is mod of x minus y dx by dy. Y-intercept of tangent is y minus x into dy by dx mod. We have to take modulus. Then there is a theorem called Rolle's theorem. According to Rolle's theorem, we can take this as x-axis, this as y-axis. Now, as per the theorem, there will be a curve f of x This f of x, you can see it is observed in between a and b. So f of x is continuous on the interval a comma b. So f of x is continuous on interval a comma b and is differentiable on the interval a comma b. Then there is at least one c such that f prime of c is equal to 0. That means here there is a point, or here there is a point on the function where the tangent is drawn parallel to x-axis and the slope of the tangent drawn at c will be 0. That is what Rolle's theorem says. Similarly, we have mean value theorem, which is similar to Rolle's theorem. So as per mean value theorem, again we can draw x-axis, y-axis, we have a curve y equal to f of x. There is a point P, x1, y1, and there is a point P or Q, x1, y1 here. Then we are observing the graph between A and B. So when you join these 2 points, you get a secant line. There is a point C in between A and B such that the tangent can be drawn parallel to the secant. So F is continuous on the closed interval. F is open on the open interval A comma B. F is differentiable. Then we can say that some important thing we can say, there is at least one C. That means C's can be more than one. So there is one C such that tangent will be parallel to secant, or slope of tangent is equal to slope of secant. Slope of tangent is f prime of c. Slope of secant, if you take the secant line AB, if you take this point as x1, y1 and this as x2, y2, slope of secant will be y2 minus y1 by x2 minus x1. That is mean value theorem. Or instead of x2 minus x1, y2 minus y1, if you take a comma f of a and b comma f of b, then slope of tangent, that is f prime of c, will be equal to f of b minus f of a by b minus a, where we can draw a tangent parallel to the secant line, and slope of secant, slope of tangent will be same. The next we can talk is if a line is bent like this, the slope is 1. If a line is bent like this, slope is 2, and so on. If a line is bent like this, slope is 3. If a line is vertical, then slope is infinity or undefined. If the line is bent like this, the slope is minus 1. For this line, slope is minus 2. For this line, slope is minus 3. For horizontal line, slope will be 0. Then we have functions called increasing, decreasing functions. Increasing function can be like this, or like this, or like this. Decreasing function can be like this, or like this, or like this. But for all increasing functions, if you draw a tangent and see, the slope will be positive. So derivative is positive means the function is increasing. Derivative is negative means the function is decreasing. Simply we know that. Next, if a function is like this or like this, then it is called concave up. If a function is like this or like this, then the function is called concave down. But for increasing functions, if x1 is less than x2, f of x1 will be less than f of x2. Whereas for decreasing function, if x1 is less than x2, f of x2 will be less than f of x1. For example, if I give you f of x equal to 5x plus 6, you take x1 less than x2, multiply by 5, 5x1 is less than 5x2. 5x1 plus 6 is less than 5x2 plus 6. So I can say that this is an increasing function. Suppose if I give you f of x as minus 5x plus 4, x1 is less than x2, minus x2 is less than minus x1, minus 5x2 is less than minus 5x1, minus 5x2 plus 4 is less than minus 5x1 plus 4. That means such a function is called decreasing function. Now there are two types of functions. Strictly increasing, decreasing functions. That means for x less than x1 less than x2, f of x1 is less than f of x2. That is increasing, strictly increasing. If x1 is less than x2, f of x2 is less than f of x1. That is simply strictly decreasing function. Whereas we have monotonic functions. What are monotonic functions? If they increase, they increase. Either they increase or decrease. That is monotonic function throughout. How can you say the function is monotonic? Monotonically increasing or monotonically decreasing? If f prime of x is greater than or equal to 0, then function is monotonically increasing always. If f prime of x is less than or equal to 0, then we say that the function is monotonically decreasing. But if f prime of x is greater than 0, then we say it is strictly increasing function. If f prime of x is less than 0, then we say that it is strictly decreasing functions. Strictly increasing function, strictly decreasing function. Maxima, minima. First, we will talk about maxima. If the function is like this, there is a maximum point here. Now, what can you say? Before the function will be increasing, then the function will be decreasing. Or before f prime will be positive, afterwards f prime will be negative. Or we can say f double prime will be negative. That is concave down. Then the function has maximum. Coming to minimum, if a function is like this is the graph of the function, then this point can be called as minimum if the function is decreasing first and then it is increasing. If the derivative is negative first and then the derivative is positive, then I can say that the function has minimum. The maximum point or minimum point can be written as something like a comma f of a, or we can say maximum, maxima or minima, whatever it is, occurs at x equal to a, or we can even say maximum or minimum value is f of a. So there are many ways of saying. Now there are two types of maximum: absolute maximum or minimum, relative maximum or minimum. If you want to find absolute maximum, what to do? You will be given a function and you will be given an interval, absolute maximum, minimum. Then first you have to find the derivative of f, set it equal to 0 and solve this equation to get x. Suppose c and d you get for x. These are called critical numbers. Now, in the function, you have to put the critical numbers c, d, and also the ends of the interval a, b. Depending on the greatest or the least value you get here, on that basis, we can select absolute maximum or minimum occurs at x equal to some value. But if you want to find relative maximum minimum, you will be given a function. You will find the derivative of the function, set it equal to 0 and solve it. If you get c and d as the critical numbers, then you will draw a number line and write c and d. Now, in between each segment, randomly you can say I'm taking p, a number p, a number q, a number r. We can pick up and then we will put it in the first derivative. Suppose we get positive, negative, positive values. Then I can say the function is increasing, decreasing, and then increasing. That means the graph of the function will increase, decrease, and again increase. So the hill will be relative maximum point, the valley will be relative minimum point. Relative or local. Also you can see. Critical numbers, critical points, critical value, stationary points, stationary numbers, stationary values, all are one and the same. If the second derivative is positive, the function is concave up. If the second derivative is negative, the function is concave down. Usually, a hill or a valley, they are called stationary or critical points given as a comma f of a. So critical points, stationary points means on hill or in the valley they exist. So on the number line, if you take points A, B, C, D and then take randomly a few numbers P, Q, R, S, T in each segment. Suppose if f prime is positive here, negative here, positive here, negative here, and positive. Whenever f prime is positive, f will be increasing. If f prime is negative, f will be decreasing. If f prime is positive, increasing, decreasing, and again increasing. This is what I have. Whenever increasing, it will go up. Decreasing goes down. Increasing goes up. Decreasing goes down. Increasing goes up. So if f prime is changing from positive to negative, there will be relative maximum. If f prime is changing from negative to positive, then there will be relative minimum. Next, inflection points. What are inflection points? Whenever f double prime is 0 or does not exist, there will be inflection point. But if this is inflection point, the derivative must change from positive to negative or from negative to positive. Then only you can call these points as inflection points. Inflection points, usually they occur when there is a sharp corner, when there is a sharp turn, or when there is a cusp. Their inflection points occur. So these are the points related to synopsis. We can start with the questions now, multiple choice questions or whatever it is. I'll start writing the questions and I'll start answering also the questions. The first type of questions we see are on velocity and acceleration. If a particle moves along according to the law S equal to t cube minus t square, then you have to find velocity at t equal to 1.5. So velocity is s prime, that is 3t square minus 2t. When you plug t square as 1.5 whole square minus 2 into 1.5, that will be 3 into 9 by 4 minus 2 into 3 by 2. That is 27 by 4 minus 3. Or 27 minus 12 by 4. That is 15 by 4. So in such type of problems, it can be used. Similarly, there is a ladder which is 5 feet long. It is resting on a wall. So this is wall and this is the ground. The ladder is 5 minutes long. Its upper end slides down. This is the upper end. The end slides down. The speed at which this distance y decreases is dy by dt. At the same time, the ladder will be moving away also. So the speed at which the lower end of the ladder is moving away will be taken as dx over dt. So in the question, the rate at which it is sliding down is given as 3 meters per second square. And then you have to find the rate at which the lower end of the sliding ladder will move away from the wall. Dx by dt we have to find. So using Pythagoras theorem, x square plus y square equal to 25. 2x dy by dt plus 2y into dy by dt, here dx by dt equal to 0. Now, if they give you the ladder is 3 meters away from the wall. So x I can put 3. Dx by dt we don't know, we have to find. Plus 2 into y. If you put x as 3 square plus y square equal to 25, y square is 16, y will be 4. So we have y as 4 and the x is given as 3. That also we have to take into consideration. So we will put y as 4, dy by dt as 3 equal to 0. So dx by dt will be equal to 24 by 6. That is 4 meters per second. Next, there are two curves. You have to find angle between the two curves y equal to sin x and y equal to cos x. So you can see when x is pi over 4, pi by 4, here also y will be 1 by root 2. Here also y will be 1 by root 2. So the common point or point of intersection of two curves is pi by 4, 1 by root 2. So in order to find the angle between tan theta we will take m1 minus m2 by 1 plus m1 m2. So m1, we will take the first curve y equal to sin x. We will find dy by dx, that is cos x. And at x equal to pi over 4, it will be 1 by root 2. Similarly, if you take cos x, dy by dx will be minus sin x, and at x equal to pi by 4 it will be minus 1 by root 2. So we can take one as m1 and the other as m2. So tan theta is m1 minus m2 by 1 plus m1 m2. That is 2 by root 2. Equal to 2 by 3 by 2. That is tan theta. Or tan theta is 2 by root 2 into 2 by 3. One minus half. So here you will have 1 minus half. And 1 minus half I will rub. 1 by 2. So 2 by root 2 into 2 by 1. That is 2 root 2. Theta will be tan inverse 2 root 2. We can do one more question. We have little time. The curves x square minus y square equal to 5, x square by 18 plus y square by 18 equal to 1 has common point as an angle. So we have to find the common point at an angle. Here y square equal to x square minus 5 and here y square equal to 18 minus x square. These are two circles. Actually, you can write it in this form also. These are the two circles. We have to find the angle between. Suppose this is x square minus y square equal to 5 and x square plus y square equal to 18. They cut orthogonally. They cut each other orthogonally. That means at 90 degrees. If 1 by a minus 1 by a dash equal to 1 by b minus 1 by b dash. So this is AB, this is A dash B dash. So 1 by 1 minus 1 by 1 equal to 1 by 1 minus 1 by 1 plus 1 by 1. Both are equal. We can do the next set of sums in the next class about these derivative applications of derivatives. Or I think quickly we will do one more question so that in the next class we can do more questions. That is the only thing for doing one more question. I think this question itself is not over. Yes, we can go to the third question. Equation of normal to y equal to x log x and parallel to 2x minus 2y plus 3 equal to 0. So we will take y equal to x log x, dy by dx product rule 1 into log x plus x into 1 by x. So it is log x plus 1. Now slope of normal will be minus 1 by log x plus 1. Slope of the given line 2x minus 2y plus 3 equal to 0 is 1. So these two must be equal. Slope of this line, which is parallel to the normal, is 1. Slope is 1. So we can set them equal. Minus 1 by log x minus 1 equal to 1. Minus 1 by log x plus 1. Or minus 1 equal to log x plus 1. Or log x equal to minus 2. Or x equal to e power minus 2. So y will be equal to x log x. That is x into log e power minus 2. That is minus 2x. So equation of normal will be y plus 2x equal to 1 into x minus e power minus 2. Because x is e power minus 2, 2x can be written as 2 e power minus 2. So y plus 2e power minus 2 equal to x minus e power minus 2. That is the equation of normal. So, as I told you, the next part We will complete it in the next class.